All right, exercise 3. Show that if B is a subset of C, then the power set of B is a subset of the power set of C. Okay, now we've gone over what B subset C means, but I think this is the first time within this exercise series that we encounter this symbol. So what does it mean? So say S is a set. What is the power set of S? Well, the power set of S, for any set S, I can't believe my horrible handwriting, is defined, and that's just what this colon equals means. If you haven't come across it before, it just means like is defined, or we define it to be the set of elements X such that X is a subset of S. Cool. So how do we go about proving this? In general, if you've taken a logic course or if you've done math proofs before, then you'll know how to do this sort of question. But in case you haven't, let's just go over it a little bit slower. So to show any, to prove any statement of the form if A then B, what you have to do is you must assume A and then show that B follows from your assumption. Okay, and let's just go over that real quick. You'll see how we do it in this example. So what do? We have if this, then that. So let's call this blue stuff. Let's just give it a random arbitrary name. I'm going to call it antecedents. And now let's take this purple stuff and let's give it some other quirky random name like consequent. Totally arbitrary. Okay, so let's assume the antecedents. So we suppose B subset of C is true. Why? I don't know. It just so happens that B is a subset of C. That's all I know. I don't know why, but it's just a fact, at least for the purposes of this proof. Now I want to show that the power set of B is a subset of the power set of C. That's good enough. Okay, so if B is a subset of C, then every element of B is a subset, is an element of C as well. So let's consider, oh yeah, and how do we show that power set of B is a subset of power set of C? We have to show that every element within the power set of B is also an element of the power set of C. So let's consider some arbitrary X in power set of B. So by construction, we must have that X is a subset of B. So let's write that down. X must be a subset of B. Now what this means is that every element of X is an element of B. But what was our initial assumption? Our initial assumption, I'm going to put it here, is that B is a subset of C. In other words, all elements of B are elements of C. So what does this mean? So every element of X is an element of B, and every element of B is an element of C. So, by our initial assumption, every element of X must be an element of C. Cool. In other words, what we're saying is that X is indeed a subset of C. So what follows from here? Well, recall that the power set of C is defined to be all elements Y such that Y is a subset of C. Just so we don't have, I use Y just so we don't have name collisions. So, how do we know if something is within? How do we know that Y is in the power set of C? How do we check that? We just check, does it meet this condition? So, X is a subset of C, meaning it meets this condition on the right-hand side. And thus, X is an element of the power set of Z. So what does it mean? What is this telling us? This means that every element of the power set of B is an element of the power set of C. Why? Why can we make that deduction? Because when we picked out X from the power set of B, we made no assumptions on it. All we said is we consider some arbitrary X in the power set of B. Any X. This must be true for any X that you pick out from the power set of B. So if what we just did shows that if you pick out any element of the power set of B, then it must be an element of the power set of C. And this is just a fancy way of saying, oh, spoilers, okay. That the power set of B must be a subset of the power set of C. And that's it. Simple proof. It seemed a lot scarier than it was. So, hope that was helpful, and I'll see you in the next video.